Good evening, everyone. Once again, I welcome you all on behalf of Inspira Research Association and KG College on the 6th day of this 7 days faculty development program come workshop on research methodology. And today we have again with us Professor Brijesh Avasthi sir. Actually, due to some personal unavoidable reasons, Dr. Dhawal Maheta could not join. So it is our pleasure that when we talked to Dr. Brijesh sir, he immediately said yes for today's session. And sir, do not need any introduction. He is a well-known academician in the field of research, and he has already taken the 4th session of this workshop. So we welcome you, sir, once again, Brijesh sir, and we welcome you and we invite you for today's session, sir. Thank you, sir.
Sir, thanks a lot.
Thank you.
Hello, everyone. Before I will start my today's session on data analytics, first of all, I want to discuss few things. That is, what exactly is hypothesis? I hope so it is clear to everyone and this topic is covered. That is, what is hypothesis, what is null hypothesis, what is alternative hypothesis, and what is p-value, what is alpha. So these are the terminology which we use in data analytics. In my previous session, I discussed about the frequency distribution, that with the help of Excel, with the help of pivot table, how you will find the frequency distribution. Today, we will discuss about the research methodology, data analytics using Excel, right? So if I'm talking about the null hypothesis, when we are going to do hypothesis testing, when we are going to do data analysis, we will frame null hypothesis. We will frame alternative hypothesis, and with the help of alternative hypothesis and null hypothesis, we will check it out that our hypothesis was correct or not. We will accept the null hypothesis or we reject the null hypothesis. Right. So I will discuss each one of them, that like null hypothesis, alternative hypothesis, according to the requirement. When I'm going to use one way analysis of variance, or one sample test, or two sample tests, or correlation and all. So simultaneously, I will discuss it with you. So now, first of all, I'm going to share my screen with you so that you can easily see what I'm going to do. So I hope it is clear to everyone, right? And I'm going to put off my camera so that this portion will eliminate. Yes, done. Okay, so you are very well aware with this data. I show you this data earlier also. That is what gender, qualification, state, IQ, height and weight. I have different data set also, but I will prefer this data set because of it is easily to understand, and everyone, even a person from management, commerce, arts, science, everyone can understand the nature of the data, right? So before analyzing the data, what we have to do, we have to check one thing in our data Excel, that we have data analysis or not. When I will click on data, like I just click on data, the data tab. In data tab ribbon, you will see in extreme right hand side, there's one option, there's one tool, that is what data analysis tool. If you will see, when you will use your Excel, when you will working in your Excel, if you will click on data and see the ribbon in right hand side, extreme right hand side, you will not find data analysis. I'm 99.99% sure you will not find data analysis, because of this is add-ins which you have to add-ins in your Excel. So how you will add in this in your Excel? It is very simple. You have to click on the file. You have, please note it down, the process, how you will include this tool pack in your Excel. What you have to do, you have to click on file. when you will click on file, in the this what we called left hand side at the bottom, you will find options. What I did, I just click on files. When I click on file, the appearance of my window has been changed, and just in the right hand side, left hand side bottom, there is one option, one tool, that is what options. You just click on options. When you will click on options, you will find this dialog box. This box is appear. And this box, the name of this box is what? Excel options. Excel options. And in the Excel options, at the bottom, second last point is add-ins. Just click on add-ins. In Excel options dialog box, which is appeared, in the left hand side, there is a list of tools, and the second last option is what? Add-ins. Just click on add-ins. After clicking add-ins, you will find there's one thing, that is what? Manage Excel add-ins, and there's one button that is written over there, is go. You just click on go. When you will click on add-ins in this dialog box, in the bottom, you will find manage Excel add-ins, and just click on go button. When you will click on go button, another dialog box is appear. Another dialog box is appear. And in this dialog box, you have some options like analysis tool pack. You have option analysis tool pack VBA, Euro currency tools, solver. So you have to click only analysis tool pack. Remember this thing, you have to click analysis tool pack and click OK. When you will click analysis tool pack and click OK, you will find data analysis tool pack appear in your data tab. If you want to install data analysis tool pack in your Excel, I will repeat the process. File, click on file, then click on options, then Excel options box. The second last option is what? Add-ins. Just click on add-ins. In add-ins, there is manage Excel add-ins, and there's one button that is go. Just click on go. The add-ins buttons appear. You just click on add-ins Excel to analysis tool pack. Just click on analysis tool pack and click OK. When you will click OK, you will find data analysis tool in the ribbon. And when you will click on data analysis, you will find this dialog boxes appear. And in this dialog box, there are several tools. That is what? ANOVA, that is analysis of variance, single factor, analysis of variance, two factor with replication, analysis of variance, two factor without replication, correlation, covariance, descriptive statistics, exponential. There are so many tools are there. This is what? T-test, Z-test, right? Regression. So these tools are appearing very easily. So first of all, we are going to discuss about one parametric test that is known as one sample t-test. This is what? One sample t-test, right? What is one sample t-test? I'm just going to show this Word file, and I'm going to give you a case. Then you will understand what is one sample t-test. There are 20 candidates in this meeting, and it's my perception that the average age of my scholars, or the average age of my participation, is 35 years. It is my perception. That is what? the average age of my participant is 35 years. So how will I check it? What I'll do, I will ask to you all, please tell me your age. So you are going to tell me your age might be 28, 35, 37, 32, 39, 24, like this. You are going to tell me your age. Then what happened? I'm going to calculate the sample mean. I'm going to calculate the sample mean. And with the sample mean, suppose sample mean is what? My sample mean is 32 years. This is what my X bar. This is my sample mean. And there is one thing that is known as, with the help of confidence interval, we will find two things. That is what? Lower limit and upper limit. This is the what? Lower limit, and this is what? Upper limit. And say, for example, my upper limit comes 36 and lower limit comes 28. And what is my hypothetical value? 35. That means 35 come at this area. Because of it was confidence interval, so I will accept my null hypothesis. I will accept my null hypothesis in this area. And in this part, I will reject my null hypothesis. What is my null hypothesis? That the average age of my participant is equals to 35. It is my null hypothesis. And my alternative hypothesis is what? The average age of my participant is not equals to 35. It might be more than 35. It might be less than 35, but not 35. Because of the confidence interval, we will find the range, upper limit and lower limit. And how we will get this upper limit and lower limit? You just look at here. The formula is upper limit. I'm talking about this part. This is what upper limit. Upper limit is equals to average plus, because of I'm considering that I'm talking about 95% confidence interval. That means 5% significance level. So average, sample average plus 1.96, because of at 5% level of significance, the value of Z comes what? 1.96. Then this is what? Multiply by standard error. Multiply by standard error. And what is standard error? Standard error is X bar plus 1.96, and standard error is standard deviation divided by under root of n. So with the help of this formula, we can get the upper limit. And similarly, lower limit is equals to X bar minus 1.96 multiplied by standard error, standard deviation divided by under root of n. We can get the lower limit also. If your hypothetical value comes between these upper limit and lower limit, you will accept the null hypothesis. That means your hypothetical mean is correct. If your value is not lie between upper limit and lower limit, that means you will reject your null hypothesis. So this is the process, right? It is very tedious process now. When I'm going to explain you how you will solve it, and there is another method also, that is what T is equals to X bar minus mu HO divided by standard deviation divided by under root of n, right? So it is a very tedious process, and when we are doing research and when we have the facility of Excel, why we will use, why we will calculate all these things manually? What we will do? We will take help of the Excel. Now just look at here. I'm just going to use this. It is my perception that the average IQ of my respondent is 20. The average IQ of my respondent is 20. This is what? IQ. The average IQ of my respondent is 20. It is my perception. So what is my null hypothesis? I have to write it down. I have to write it down that my null hypothesis is, that is what, average IQ is equals to 20. And what is alternative hypothesis? That average IQ is not equals to 20. Right. Now I'm going to test it with the help of Excel. How will test? First of all, just go click on data, then go to the data analysis. In data analysis, you just go down. This is what t-test paired to sample. T-test paired to sample. Oh, it is not. This is not a case of paired sample, no? Okay. Then t-test sample assuming equal variance. Then t-test sample assuming unequal variance, and z-test to sample mean. There is no option for one sample test. If there is no option for one sample test, what we will do, we can calculate it with the help of this t-test to sample assuming unequal variance. Assuming unequal variance. How we will test it? Just click OK. When you will click OK, you will find a dialog box, and here you will find variable 1 range and variable 2 range. Variable 1 and variable 2. So what I'll do, I'm just going to take the input of first variable. I'm just going to take input of first variable. That is what my main variable. That is what IQ. But we don't have second, because of it is one sample test now. So we don't have second variable. So what I'll take, I will take this. This is what? Any other variable. You just take 2 or 3 values, right? And this is what hypothetical mean difference which you are considering. Which you are considering. I was considering the hypothetical mean difference is what? 20. Hypothetical mean. And I have included the label. And this is what? Output. I want output on new worksheet. Right. I want output of new worksheet, and click OK. When you will click OK, you will find it. Now, you will say, sir, you applied 2 sample tests. Agreed, I applied 2 sample tests. But we can get the closest value because of I have taken only 3 sample over there, right? And this is what hypothetical mean difference is there. You just delete this part, delete, and consider as a 1 sample test. And here you will see what is the, because of it is 2-tailed test, you just focus on this part. What is the p-value? P-value is 0.0013. P-value is what? 0.0013. That means the p-value is less than 0.05. The p-value is less than 0.05. Right? Because of p-value is less than 0.05. Please note it down. It is very important. If the significance value is greater than or equals to 0.05, what happen? Accept null hypothesis. We accept the null hypothesis. And if significance value is less than 0.05, what happened? Reject the null hypothesis in favor of alternative hypothesis. So in my case, my significance value is 0.003, which is what? Less than 0.05. So what happened? I will reject the null hypothesis. I will reject the null hypothesis. If I'm going to reject the null hypothesis, so in favor of alternative hypothesis, I will accept the alternative hypothesis. That means the average IQ of my respondent is not equals to 20. Let's see what exactly is average IQ of my respondents. Because of my hypothesis wrong now. If my hypothesis is wrong, then I want to check what exactly is average IQ of my respondents. I'm just going to click just equals to AVERAGE average and just take the values and just enter and see 17.89. Yeah, 17.89. And what was my hypothesis? That average IQ is 20. So definitely my perception is wrong. When actually the average IQ is 17.89 and I'm going to assume that average IQ is 20, so it definitely is going to be rejected. Now, if I'm talking about the two sample test, what exactly is two sample test? This is also very interesting. And we rarely use one sample test in our study. Why? Because of it is very difficult to get some hypothetical value to test the hypothesis. Otherwise, what happened? Or we can take the hypothetical value on the basis of literature review or on the basis of some other formulas and equations. So it's going to be challenging. If we talk about the two sample test, it's a very common test. And I'll give you one wonderful example of two sample test. Like in my case, I'm just going to assume it is what my null hypothesis. I'll change the color of my pen. This is what my null hypothesis, that there is no significance difference between IQ level of male and female. There is no significant difference between IQ level of male and female. It is my null hypothesis. That is, there is no significant difference. If we mathematically we will write, so we can say that average IQ of male is equals to average IQ of female. It is my null hypothesis. And what is my alternative hypothesis? If we talk about the alternative hypothesis, it shows that there is a significance difference between IQ level of male and female. We are not saying that IQ level of male is more or female is more. It is my perception that average IQ of male and female are equal, and alternative is what? Average IQ of male and female are not equal. So in the equation point of view, we can say that is my alternative hypothesis. Average IQ of male is not equals to average IQ of female. This is what my alternative hypothesis. How we will check it? How we will analyze it? If you will see my data, this is what the gender, where we have male and female, and this is what my IQ. So I can get the average IQ of male, I can get the average IQ of female, but statistically we have to analyze it. How we will analyze it statistically? You just look at here. We have to do some changes in it. And what are those changes? Now, just come on. Oh, control chat. Now you just look at here. I'm just going to shorting short. This is what females come first, and this is the data of female. So I'm going to take data of female. You just look at here. I'm just going to copy the data of female. Yes, this is data of what? Females. Control C. And on new workbook, I'm going to paste. This is what data of FEMALE, females. This is the IQ of females. Next is what? I'm going to take IQ of male. And this is the IQ of male. Just Control Shift, Control C, and come back and Control V. And this is what? Male. Right. This is the IQ data of male and female. Now the process is same. Now question is this, before we will apply two sample tests, and as you know it very well, when we are going to check it, that is what data analysis. In data analysis, we have t-test, two sample assume equal variance, t-test, two sample assuming unequal variance. What do you think that the variance in the females data and variance in the males IQ are same or not? What do you think? Because of they belongs to same population, they belongs to same category, so it is my perception that the average, the variance among the male and females are equal. They belongs to the same population, right? It is my perception. So I'm just going to use it, the equal variance. Just click OK. Now in this table, that is what t-test, two sample assuming equal variance. The input is what? Variable 1 range and variable 2 range. I will take variable 1 for female's IQ. This is our female IQs. Then click on the next. That this is what our male IQs. So we have copied. We have provided the range of male IQ and female IQ. What was our perception? Our perception is this: there is no significant difference between male IQ and female IQ. There is no significant difference. When there is no significant difference, that means difference must be 0. The difference must be 0. So I just put the value 0. Then when we select the data, you have remember I included the male and female while selecting the data. So label is there. So I have to click on labels. Otherwise, it's going to give you error. Because of the rest of the values are numerical, but male and females are character now. So it's going to give you what? Error. So you have to take label. And what is the value of alpha? That means your significance level. 5%. That is why 5% is there. If you want to change it, you can change it. For example, %. Suppose you want to analyze this hypo testing using 1% significance level. That means 99% confidence level. Or you want to analyze it at 10%, you can use this 0.1, 10%. But normally we can see the 5% are most recommendable significance level. Right. So I'm going to take only 5%, 0, 5. This is what 5% level of significance. And where you want the output? On new worksheet, ply, just click on it and click OK. Now you will see we got the result. We got the result. And what result is showing, what result is discussing? You just look at here. This is what? Mean of females IQ is 17.88 and mean of males IQ is 17.91. That means average IQ of female is 17.88, average IQ of male is 17.91. So like if we talk about the on the basis of the average value of IQ of male and female, we can say there is no significant difference, right? But we want to check it, we want to prove it statistically. So definitely we will concentrate on the p-value, right? Just below the mean value, we have variance. Variance in IQ of male is 2.51. Variance in the IQ of male is 2.61. The observation, that means number of cases. In female, 296, male, 304. And the pooled variance, that means combined variance is 2.38. And hypothesized mean difference, okay, because of it was our hypothesis that there is no significant difference. When there is no difference, that means the hypothetical mean difference is what? 0. So this is what hypothetical mean is 0, difference mean is 0. Then degree of freedom is this. This is what t value of t. But we will not focus on the t statistics. We will directly see the p value. Okay. Number 2, which is very important, that while we are analyzing the data, that it is one sample test or two sample test. When I'm given the hypothesis that there is no significant difference between male's IQ and female's IQ, right? Or when we talk about the alternative hypothesis, yes, there is a significant difference between male IQ and female IQ. That means if male IQ is more than female IQ or female IQ is more than male IQ, it doesn't matter for me. I'm not going to check it out. Like male has more IQ or female has more IQ. I don't want to check it out. So I'm looking for two-tailed test. Because of it doesn't matter for me ki IQ of male or female are more. So I'm just focusing on this part. That is what two-tail test. Two-tail test. I'm just going to considering that average, the mean difference must be 0. Right? I want this. If mean difference is more positive, if mean difference is negative, so that means it's not equals to. So we will accept the alternative hypothesis, and in this part we'll accept the and just a minute. In this part we accept the null hypothesis. We accept the null hypothesis. In this case, we accept the alternative hypothesis. So in this case, our p value is what? P value is 0.8017, which is more than equals to 0.05. When p value, significance value is more than 0.05, that means what? 0.8017. What will be happen? We will accept the null hypothesis. Yes, there is no significant difference between male's IQ and female's IQ. If we talk about the another case, suppose I am saying female has more IQ as compared to male. What is my null hypothesis? My null hypothesis is this, that average IQ of female is more or equals to average IQ of male, then what is my alternative hypothesis? That is what average IQ of female is less than average IQ of male. So what is my perception? What is my hypothesis? That average IQ of female is more or equals to average IQ of male. It is my perception. It is my null hypothesis. And what is my alternate hypothesis? That the average IQ of female is less than average IQ of male. But remember this thing, we never use greater than or less than in null hypothesis. We always put equals to. If it is here equals to and here we have less than, so by default, we will consider that greater than part must be here only. And it is hidden. It is not visible. Number two, when we have either less than or greater than an alternative hypothesis, it's going to show us that it is one sample test. Which one? It is one sample test. If our alternative hypothesis is showing that either less than or greater than, it is one sample test, or if it is going to show that not equals to, that means going to tell us what? It is two-tailed test. Because of here we have less than sign, that means it is what? One sample test. So we will not focus on two-tailed test. We will not focus on two-tailed test. We will focus on what? We will focus on one-tailed test. Right? Okay. Because of less than sign, one-tailed test. Greater than sign, one-tailed test. Not equals to two-tailed test. So we have less than sign. That means what? One-tailed test. Now, you just look at here the p-value. What is the p-value? That is what? 0.40086. Again, this value is more than equals to 0.05. That means you accept the null hypothesis. You accept the null hypothesis. That means there is no significant difference between this. Yes or no? If it is less than 0.05, that means you will reject. When rejection comes now, you will check it's going to reject in left hand side or right hand side on the basis of the average IQ. I hope so it is clear to everyone. If you have any doubt, please ask me. I request you, if you have any doubt, please ask me and in the chat box, please. Okay, so no message, that means there's no doubt, right? So I'm going to continue my session. So it is about the two-tailed test. When we talk about one more thing, that is what? Suppose we have more than two samples. I'll give you one example of it. If I'll say we have three products like Bonvita, another is what? Horlicks, and third one is what? Complan. Bonvita, Horlicks, or Complan. Can we say that Bonvita is going to provide you a high level of energy, or Horlicks is going to provide you a high level energy, or Complan? I want to check it. I want to test it. So what will be my perception while I'm going to test it? What is my perception? My perception is this: average of first group is equals to average of second group is equals to average of third group. That means it's going to show me there is no significant difference between health drink as far as concern of energy level. Even you are having Bonvita or Horlicks or Complan, it doesn't matter. You will get almost same energy level. It is my perception. Then what is alternative hypothesis? My alternative hypothesis what? Ki at least one group behave differently. At least one group behaves significant different from others. At least one. Why I'm saying at least one? Because of if this is not equals to this, but group 2 is equals to group 3, or average of 1 equals to average of 2 is not equals to average of 3. And third possibility is what? Average of 2, average of 1 is not equals to average of 3, right? So in this case, it is not equal. In this case, it is not equal. In this case, it is not equal. It might be the 2, group 2 is equals to this, or group 2 is equals to this. It is quite possible. But at least one group behaving differently. When we have more than 2 group, when we have more than 2 group, we will use analysis of variance. I hope so it is clear to everyone. So if you will see in my data set, we have persons from different qualifications like PhD, undergraduate, professional. And my perception is this: the qualification affect the IQ level. That means the average IQ of PhD candidates and average IQ of undergraduate, average IQ of postgraduate, average IQ of professional are same or not. So what will be my null hypothesis? My null hypothesis is, it is my null hypothesis what? That average IQ of PhD is equals to average IQ of post-graduation equals to average IQ of professional is equals to average IQ of this undergraduate. That means there is no significance difference between groups as far as IQ concerned, that the IQ level of different groups are same. It is my null hypothesis. What will be my alternate hypothesis? That is at least one group IQ level is different from the other groups. At least one. And we can easily check it. How we can check it? Again, we have to sort our data on the basis of IQ. We have to sort it down. A to Z. This is what. Now, this is what post-graduation, then PhD, then professional, then undergraduate. So what should we do? We have to copy paste, right? I'm just going to take the data. This is what IQ of post-graduation I have to scroll down slowly because of it's going to jump in another category. Yes, come on. Yeah. So post graduation is complete. Control C. I just going to take new sheet. Control V. This is what post graduation PG. Then if I'm talking about the PhD, I'm going to select PhD. This is what PhD. I'm going to take the data of PhD candidate. Definitely you are thinking that, sir, it is also a tedious process to short it down, then copy paste. I'll give you another method how you can take the data on the basis of single click. Although you have to do copy paste in that case also, but on the basis of the single click, you can get it, right? This is what Control V, and this is related to what? PH.D, because of heading is also important, no? Which group is going to behave differently. So now at this turn of professional, oh, professionals are very less. Professionals are very less. This is what professionals. Control C, then come to the sheet and Control V. These are brought PROF, professionals. Then last is what? Undergraduate, right? I'm just going to take the data of undergraduate. These are the candidates, undergraduate, Control C, and Control V. This. Now, the data is ready. And we are ready to analyze the analysis of variance. How we will analyze it? Just go to the data, then data analysis. In data analysis, on top, you will find analysis of variance. Single factor, analysis of variance, single factor. Just click on analysis of variance, single factor, and click OK. You will find ANOVA single factor dialog box. And here we have one input range, right? And here we have to select the data. I'm just going to select the entire data, including labels also, right? So now you are thinking, sir, there are so many cells are blank. So it doesn't matter. It's not going to consider the blank cells. But we have to select the data likewise only. Then number 2 is what? Your data is grouped by column. Yes. First column is postgraduate, second is PhD, third is professional, fourth one is undergraduate. So your data is grouped by column only. Then labels in first row. Labels in first row. And your significance level is what? 5%. Alpha is what? 5%. That is significance level. And now just click OK. Now you will find your result is ready. Your result is ready. Your result is in front of you. And you can easily analyze this data. If we talk about our groups, we have 4 groups. That is what? Postgraduate, PhD, professional, and undergraduate. The first value shows what? Count. That is, there are 110 candidates who are postgraduate, 182 are PhD, 142 professional, and 166 undergraduate. Which I told you, it doesn't matter how many like you are going to select the entire data and they are empty cell. It's going to count only fill cell. It's not going to take the empty cell. It's not going to consider the empty cell. And this is what total of this. average, because of we are working with IQ, na? Like, is there any significant difference between groups as concern of IQ? So this is what average of IQ of PhD candidate, postgraduate, professional, and undergraduate. So if you will see 17.75, 18.04, 17.94, 17.75. So as far as visualize effect, there is no significant difference, right? On the basis of average, and variance is almost same, that is 2.44, 2.48, 2.37, 2.22. So variance is almost same. If we talk about the ANOVA table, this is what ANOVA table, and it's going to show you sum of square, degree of freedom, mean of square, F ratio, P value, and the critical value. P value is most helping us, because of if otherwise if we will not consider the P value, if we are not going to consider the P value, in that case we have to compare the F value with critical value, F test value with critical value, but we have P value, so we will take the benefit of it. What is the P value? P value is 0.3262, 0.3262, which is more than equals to 0.05, more than equals to 0.05. It shows that you will accept the null hypothesis. You will accept the null hypothesis. If you are going to accept the null hypothesis, that means there is no significant difference between the groups. That means IQ level in different groups are same. Sir, we applied so many tests, like one sample test. In one sample test, our hypothesis was rejected because of we have taken 20 as IQ, average IQ. That was not the actual average IQ of the our sample or our group. But in case of two sample tests, or in case of analysis of variance, we are going to accept the null hypothesis. You just tell me a few cases so that we can easily understand, yes, this Excel is working. Like, I'm going to give you another example of it. Just I'll take the sheet. I will take the sheet, right? I'm just going to delete.
Sir, excuse me, sir.
Yeah, please.
Sir, I have one doubt, sir.
Yeah, please.
Sir, I have created a null hypothesis, alternative hypothesis, sir. That is, there is effectiveness in students' pronunciation from a PhD, sir. And my P value is 5.81, sir.
5.81.
Yes, sir. And my hypothesis is there is effectiveness in students' pronunciation after learning through flipped classroom modules on specific feature of pronunciation based on select cognitive domains. This is my hypothesis.
Right.
And my P value is 5.81.
P value is 5.81.
Yes, sir.
It is completely impossible because of your P value is lie between 0 to 1 only.
Okay, sir.
P value cannot be more than 1. P value cannot be like a negative. The minimum value is 0 and the maximum value is 1.
My value is 5.81222 somewhere value is lacking, sir.
Can you repeat it? 5.81
222
222
sorry, E-64.
So it is almost 0.0000.
Okay,
right?
Sir.
Because of the e raised to the power minus 64, na?
Yes, sir. It is minus 64, sir.
right? So it's going to be 0, 0, 0, 0, 0. You can consider as a 0, 0, 0. When the
Okay, okay,
p-value
sir.
is 0.00, which is
Yes,
less
sir.
than 0.05, what you will
Okay,
do?
sir.
What you will do? Yes,
Reject
try.
the,
You
yes,
will
sir.
reject the null hypothesis and accept the
Alternate hypothesis.
alternative hypothesis,
Yes, sir. Okay, sir.
right?
Yes, sir.
Okay.
Thank you, sir.
Welcome, welcome. Now, I was discussing why like I got the p-value is 0.3262. Sir, can you give us some case so that we can understand like p-value is 0.000, like less than 0.05, so we can understand yes, it's working. Okay, I'm just going to give you a case. You just look at here. Suppose we have a category, say W, category is W, X, Y, and Z, right? 4 category, and values are 12, 15, 13, 16, 19, 10, and 15, 13, 16, and Y is 10, 9, 15, 14, 16, 15, 18, 12, 12, 15, 17, 10, 11, and third category is what, say 13, 18, 19, 17, 14, 16, 15, 10, 10, 11, and Z is what, 25, 19, 10, 28, 25, 21, and 38, like this. I'm just going to check whether my hypothesis is true or false. What is my hypothesis? That there is no significant difference between the groups. Group W, X, Y, and Z. What I do, just go to the data, then data analysis, analysis of various single factors, select, then select the data. This, I have select the data. It is column, first row, this, and click OK. When I will click, I will get the result. Now you will see the result. What is the p-value? What is the p-value? Yes, come on, everyone.
Sir,
0.00.
0.0010.
00, sir.
0.000. That means this p-value is less than 0.05.
So we are accepting the null alternative hypothesis.
Yes. So what you will do, you will reject the null hypothesis and accept the
Alternative hypothesis.
alternative hypothesis. And what alternative hypothesis saying? That there is a significant difference between the groups by at least one group. Yes or no? At least one group is different from the other. Of which group is going to differ? You just look at here the average value. What is the average value?
Less than
14.333. 13.3846. Group Y 14.3. But if you will see, the group Z is behaving differently. Yes or no? So who is culprit? Group Z. Can we do one thing? If I will apply the analysis of variance among these 3 groups, so we must get there is no significant difference now between WXY. Yes or no? Let's try.
Yes, sir.
Let's try. And let's see what happened. Again, I just go to the data analysis, ANOVA single factor. Just I'm going to select only 3 groups. I'm not going to select Z because of I found that group Z is behaving differently. That is why I eliminated. I'm just going to focus on the W, X, and Y. I just click OK. When I click OK, I got this output, and let's see what is the value of it. Wow, the value of P is more than equals to 0.05 now. Value of P is more than equals to 0.05. What it shows? That there is no significant difference between the IQ level of among these 3 groups. Am I right or wrong? Yes or no?
Yes, sir.
Right. So it is clear. I hope so. It is clear to everyone.
Yes,
With the help of Excel, we can check 1 sample test. We can do 2 sample tests, even it is equal variance or even it is unequal variance. And we can check analysis of variance also. Right? One more thing. That is, definitely you are aware with F test. Have you have an idea about F test? What is F test? There are 2 things, F ratio and F test. F ratio, we will calculate F ratio in analysis of variance. But if we talk about the F test, when we want to compare the variance of 2 groups, suppose I will show you one thing. This is Control or Delete. This is my population. This is what? Population. And I'm going to draw 2 samples from it. This is what sample 1 and this is sample 2. When I draw 2 samples from one population, what do you think that the variance of sample 1 and variance of sample 2 must be equal or not? What do you think about it? Yes, everyone. Definitely, the variance of sample 1 and variance of sample 2 definitely must be equal, because of these 2 samples are belongs to same population. And reversely, I will ask, this is what my sample 1. And this is what my sample 2. And I want to check, like my sample 1 and sample 2 are belongs to same population. Are belongs to same population or not? How will I check? This is one method, that is what? If the variance of sample 1 is equals to variance of sample 2. If the variance of sample 1 equals to variance of sample 2, it shows what? It shows what? That means if the variance of sample 1 equals to variance of sample 2, it shows that these 2 samples, that is sample 1 and sample 2, belongs to same population. If variance of sample 1 is not equals to variance of sample 2, it is not belongs to same population. That means they belongs to, say, a different population. I hope so it is clear. The concept is clear or not?
Yes, sir.
So what I will do again, come back, and I'm just going to Control X and Control V, right? Suppose we have two sample W and X. We have two sample, right? And I want to check that these two sample are belongs to same population or not. These two samples are belongs to same population or not. What should we do? We have to apply F test. Just go to the data analysis. In data analysis, you will find F test to sample for variance. Yes or no? Just click OK. This is what in this dialog box. First is variable 1 range, and second is what? Variable 2 range. Variable 1 range and variable 2 range. So this is what your variable 1, and this is what your variable 2, right? So variable 1 and variable 2. Now, because of we selected the label, so we have to check it. Label, then alpha 5%. Output on new worksheet ply. Just click OK. Let's see what happened. Oh, results come. And what is result? What result is saying? That is average of first group is 14.33. Average is second group is 13.38. Variance of first group is 7. Variance of second group is 8.42. Right. And this is what observation, that means number of the item, that degree of freedom. Now this is what F ratio, this is what P value, because of we focus only on P value, right? What is our P value? 0.40. 0.40, that means it is more than 0.05. So we will accept the null hypothesis. We will accept the null hypothesis. When we will accept the null hypothesis, what null hypothesis is saying? What null hypothesis is saying? That is, there is no significant difference between the variance of sample 1 and sample 2. There is no significant difference between the variance of sample 1 and sample 2. It is my null hypothesis, and we accept it. Yes, there is no significant difference. You just see the variance. This is what 7, this is what 8.42. Now, if we'll come back to the question, now I want to test that variance of group Y and variance of group Z. That means the group Y and group Z are belongs to same population variance, and we will check it. How we will check it? How we will check it? Very simple. Just go to the data, then data analysis, and come back to the this F. OK, and select the variable range 1. This is what my variable range. Then this is what my variable range 2, and just click OK. Results comes, just increase and check the value. Now you will see what is the P value. P value is 0.005, which is less than 0.05. That means this value is less than 0.05. So it's going, that means you are going to reject the null hypothesis. That means group Y and group Z are not belongs to same population. Not belongs to same population. As you can see, the variance of sample Y is 10.67 and the variance of sample Z is 73.90. The variance of sample 1 and sample 2 is, there's a lot of difference. That means they are not belongs to same population. And it is very simple. If you are going to draw two sample from the one population, it is sure that the variance among the sample you will find almost equal, not exactly equal, but almost you will find the equal variance. There's no significant difference between the variance of these sample. So this sample is where this test is very important. And when we will take this test, suppose we are going to do a study and we are going to generalize one statement. Before the generalize that statement, we have to check that the variance of these groups are same or not. Have you have an idea about what are the assumptions of this parametric test? There are two types of tests, na? Parametric and non-parametric test. When we talk about the parametric test, there are some assumptions, right? And what are those assumptions? I just show this slide. That is what? These are the assumption of parametric test. What are the assumption? Number one, normality. The data must be normally distributed. If you are going to check the normal distribution curve of your data, if curve is like this, that means it is normally distributed. Or with the help of PP plot or QQ plot, PP plot or QQ plot, you can check the normality. Otherwise, I am going to tell you a wonderful method to check the normality of data. And that is very simple. That is known as box plot. That is known as box plot. With the help of box plot, you can check the normality. Right. So how we will check the normality of the data? Discard, just come back. This Excel. Right. Okay. So it's going to just come upper side. Okay. So this is what sheet number 1. I want to check the normality of my data. How will I check? I have to remove first this. Right. So I want to check the normality of IQ, that my IQ is normal or not. So how will I check? I just select the data of IQ. I just select the data of IQ. Then go to the insert and recommended chart. Go to the all chart. In all chart, there is a box and whisker chart. Just click and click OK. You will find this chart. Right. You just see. If you will see this chart, I will just change the color of this chart, right? Just a minute. I will change the color of the chart. Fill color. Yes. This. Now you just look at here in this chart, you will find this cross sign is going to tell us the mean. It's going to show us mean, and this vertical line shows median, and the upper line is known as Q3, third quartile. The below bottom line of this box is Q1, first quartile. This line shows minimum and this line shows maximum. If the distance between the median and Q3, median and Q1 is almost same. Q3 to maximum, Q1 to minimum, right? And this median line is very close to mean value. It's going to show us it is normally distributed. It is normally distributed. Another method is that is descriptive statistics, which we discussed in a previous session. I hope you have remembered the previous session, right? Again, I am just going to select the data, Control Shift up arrow. No, it's not working. I don't know why it's not working. I just select my data again. Right. Oh, so, okay. I have selected, labeled this, and summary statistics, and click OK. So you will find the data, and you just look at there the value of skewness. If your value of skewness is close to zero, it's going to show you that it is normally distributed. Close to zero. Because of 0 to this side, 0 to this side, it's going to show negative, it shows positive. If your value is large, just close the 0. It's going to show it is what? Normally distributed. So with the help of this, you can check that your data is normally distributed or not. So this is what the first point. Second is what? Homogeneity of variance. Homogeneity of variance says that data from multiple groups have the same variance. If you have remembered, we have different group now, like W, X, Y, Z, right? So when we are going to apply the parametric test, our group of the variance among the group must be equal. The variance of group X is equals to variance of group Y is equals to variance of group Z. If variance of these groups are not equal, it shows that there is no homogeneity between the variable. And if homogeneity is not there, you cannot apply parametric test. It is the essential assumption, condition. Number 3 is linearity. Number 3 is linearity, that data have a linear relationship. Data have a linear relationship. What is the linearity? What is linear relationship? What do you think about it? Linear relationship shows that data, this is what X and this is what Y. This is our independent variable. This is what our dependent variable. If we will find the relationship between, it's going to show us the linearity. And number 4, independence. Data are independence, like data of one variable should not be affect the data of another variable. Like in terms, like if I'm saying I'm going to collect the data. Independence means what? I'm not talking about this X and Y. I'm talking about the observation. This is what my X, this is what my Y. If I will say it is what observation 1, value is 10 and 12, and observation 2, it's 12. The dependency between the between the among X variable, like between 10 and 12, should not be there. It should be independent. That means observation 1 is not going to influence the observation 2. Otherwise, what happen? If observation 1 is going to influence observation 2, definitely the impact is going on this. So we are not able to find the relationship between the variable X and Y. We are not able to find the actual relationship, actual effect of independent variable on dependent variable. So these are the 4 important assumptions of parametric: normality, homogeneity, linearity, and independent. And definitely you are 100% aware with the correlation, 100% aware with the regression. You will find the same assumption in the regression, that data must be normally distributed. What do you mean by the data must be normally distributed? What is the homogeneity of variance in between the group in case of a regression analysis? You just look at here. I'm going to show you. I just where is insert? Yes. You just look at here. This is what my line. I just make it bold, and I will draw another line, and I just make it bold also. Now, what happened? This is what my scattered plot. I'm going to draw a scattered plot, right? I'm just going to draw a scattered plot. And after scattered plot, what will we do? What we will do, this is what a regression line on the basis of ordinal least square method. Regression line on the basis of ordinal least square method. And in this case, there's one assumption that data is normally distributed. What do you mean by that data is normally distributed? The meaning of this data is normally distributed is this: if I'm talking about a particular value of X, this is the value of X1. And for this X value, there must be many values like this. Now you will see the density of dots are more close to this. That means this must be normally distributed. This data, the value of Y, when value of X is fixed, say X is equals to 10, but Y might be 15, 12, 14, 13, 14, 15, 10, 11. So this is what, if you will draw a scatter, if you will draw a normal distribution of this, it should be like this. When X is equals to 10. So this is what normally distributed, number 1. Number 2, the variance for the X1, similarly the variance for the X2. The variance for the X2 is equals variance for the X1 is equals to variance for the X2. This is called homogeneity. That means there is a homogeneity between the variable, right? So we have to check very minor thing before we have to decide that we are going for the parametric test or non-parametric test. And the reality is this: when you will analyze your data, you will find that your data is not normally distributed. Your data is not normally distributed. When your data is not normally distributed, how you will apply for parametric test? Because of it is an assumption. It is prerequisite that your data must be normal distributed. So the solution of it is what? If you will increase the sample size, then your data is not normally distributed. Okay, we can take it easily. That means we can consider it as a parametric. Listen me carefully. Suppose you have taken a small data set like 20, 25, 40, and you are not going to find the normality among your data. What you will do? You just increase the sample size. When you will increase the sample size like 200, 25, 250 or 300, then you are not going to find the normality. It's okay. Then it's considered as a parametric. So there are some way outs to consider it. Similarly, one more thing. You are very well aware with four things. That is what data has four different measures. Number one is nominal. Number two, ordinal. Number three, this interval, and number four is ratio. Say yes or no. When we are going to apply data analysis, or when we are going to apply statistical analysis on the variables, we have to take care of their measurement of scale also. I tell you one thing, and you will find such mistake in surrounding you also. Sometimes what happen? People will calculate the average of gender. Average of gender. If I'm talking about gender, gender is what kind of measurement? Nominal. Gender is what? Nominal. And you are going to calculate average of it and say average is 0.62. Because of you coded that male is 1 and female is equals to 2. Sorry, female is 0. Male is 1 and female is 0. And what happened? You just calculate the mean average of gender. When it's a nominal measure, your data is nominal measure, and you applied the gender average, you will get this. It is totally meaningless. If I'll ask to you, what's the meaning of? Can anybody tell me what's the meaning of it? That average gender is 0.62. Yes, come on. Come on, everyone. Okay, sir, can you explain it with the help of your analysis? Sure. This is what my gender. I'm going to do the descriptive analysis. Just a minute. Descriptive statistics. This, and I have selected the entire data and click OK. Because of these are what? Text now, it's not going to perform it. So what we have to do? We have to code it. I'm just going to code it. What? Control Shift Enter, Control F. I will write Alt R. That is what? FEMALE. Female is replaced with 0 and replace all. Okay. And male is replaced as 1. Replace all. Okay. Similarly, I am going to control down. I'm going to write undergraduate replace as 1. Okay. and postgraduate replace at 2. You have to coding your data. Without coding, you cannot analyze, right? It's going to work in this pivot table, but for numerical calculation, you have to convert into the coding. Then PROF, professional as 3, replace all. And last one is what? PH.D is known as 4. So I just given the coding, and just a minute, I'm just talking about the last column also. Last column. That is what it states. So that we will analyze and you will enjoy a lot. Seriously, definitely you will enjoy. That is what Rajasthan as 1, replace all. Okay. Then Delhi as 2, replace all. Okay. And MP as 3, replace all. And Maharashtra as 4, replace all. Okay, one state left, that is what? UP. So UP as 5, replace all. Okay, close. Now you will see I have convert my data into the numerical form, right? So I'm going to analyze descriptive analysis of this data. Just go to the data, then analyze and descriptive statistics. I have selected that and click OK. Wow, I got the result and I'm going to analyze it. Control V, Control X, Control V, Control X, Control V, Control X, Control V, Control X, and Control V. And Control X and Control V. Oh, Control X and Control V. Just I'm going to delete this repetitive thing. There's no need of such repetitive tools. Delete. Now. Yes. Now I request you just tell me what's the meaning of it. You have to explain. It is a interactive session, not one-way communication. Can anybody explain what's the meaning of this average gender is 0.5066666667? Can anybody tell me? What's the meaning of it? What inference you will draw from the mean of the gender? Yes, anyone from you all?
Sir, gender is equal, male and female, almost.
Gender is equal. So with the help of frequency distribution, you can prove it. That is, in my respondent, there are 296 are female and 304 are male. That is also possible from that. Like, what's the meaning of it? If I will draw the meaning from this statement, I can say कि your average respondent is 0.50. That means your respondents are converting from male to female or female to male. Or we can say, I can draw the conclusion that is your respondents are neither male or nor female. Yes or no? Yes, everyone.
Yes, sir.
That means your respondents are neither male nor female. So it is not a meaningful, right? If we talk about the mode is 1. 1 stands for what? Male now? 1 stands
Yes,
for
sir.
what?
Yes,
Male.
yes.
That means the maximum participant of your respondents are male. So only one information is valid in case of a gender, that is what? Mode. We will not draw any inference from mean, standard error, median, standard deviation. There's no use of it. Got my point? Because of gender is nominal. If we talk about the qualification, average qualification is 2.56. Can you tell me the meaning of 2.56? You will say, sir, 2 means postgraduate, yes or no? 3 means professional. That means your respondents are lie between postgraduate and professional. No, because of again qualification is ordinal data. Yes or no? And in case of our ordinal data, we have two valid things, that is median and mode. Rest of the things are useless. If I am talking about state, if I am talking about the state is nominal data. State is what? Nominal. Because of we cannot put states in order. Like Rajasthan is on top, Delhi is on bottom, or Haryana or Punjab or Uttaranchal in mid. We cannot say. There is no differentiation between the states as far as their order concerned. So it is nominal. So again, it is useless. So which is meaningful? Sorry. Which is meaningful? Only mode. That is maximum respondents belongs to Delhi. Because the 2 is here, na? And 2 stands for Delhi according to our coding. Now we are talking about the IQ. IQ is numerical value. That means scale. Height is what? Numerical. That means scale. Weight is numerical. That is what? Scale. So IQ, height, weight are what? Ratio type of ratio scale variable. Ratio scale. And the average is clearly meaningful. That means average of IQ is this. Average height is 61.21. So in ordinal, you can say in nominal, we can calculate only mode. In ordinal, we can calculate mode and median. Numerical value, numerical. We can calculate mean as well as mode, as well as median, standard deviation and all. I hope so it is clear to everyone.
Yes, sir.
So before you are going to proceed for analysis of your data, you have to decide it first. You have to decide it first, like your data is nominal, ordinal, scale, or what. And according to this nominal, ordinal, scale, and all, you have to decide which statistical you have to use. If we talk about the chi-square test, which I discussed very brief in my previous session.
Yes, sir.
In chi-square test is basically a non-parametric test. Now you will ask, sir, what is non-parametric test? And what is parametric test? You are talking about the assumption, but you haven't discussed about the meaning of parametric test. Parameter is what? The characteristics of population, right? The characteristics of population. Basically, we have two things. This is what? One, and this is what? Small thing. The bigger thing is known as population. A small thing is known as sample. And from the population, we will get the parameters, and from the sample, we will get the statistics. So this is what parameters are belongs to population and statistics are belongs to sample. So when we want to say something about the parameter on the basis of sample, what we will do? We will do parametric test, because we are going to check the parameters on the basis of what? Sample. Because of it is very difficult to analyze the entire population. We don't have enough time. We don't have enough budget. And we want our result, we want to finish our study as soon as possible. We have to reach a conclusion as soon as possible. That is why we will not analyze the data of entire population. What we will do? We will take a small sample from the population. We will take a small sample from the population. And after taking a small sample from the population, we will get the inference and we will relate it to the parameter. This is called parametric test. Suppose there is no parameter. Like if I'm saying the IQ, if I'm saying the IQ is parameter, IQ of population, average IQ of population and average IQ of sample. So on the basis of sample mean, I'm going to say about the population mean. But sometimes it happens, we don't have such things. We have only frequency, which I told you. Okay, suppose out of 100 females, pregnant females, they have given birth to 65 baby boys and 35 baby girls. 65 baby boys and 35 baby girls. Now, can you tell me, is there any parameter? No, there is no parameter. There is only numbers, count, frequency. When we have numbers, count, frequency, that means we don't have parameter. And when we don't have parameter, how we will do parametric test? In that case, we will apply non-parametric test. So chi-square is what? Non-parametric test. Gotten my point?
Yes, sir.
Chi-square is what? Non-parametric test. And then what we will do, actually the formula of this, this is what babies, boy or girls, 65, 35, right? This is what observe, which you find it. And then next is what? Expected, which we discussed. Ki out of 100, there must be 50 boys and 50 girls. What we will do? Observe minus expected. Then you have to do square of it. Then divided by expected. Then you have to total of it. Total of observe minus expected whole square divided by expected. This is known as chi-square. Then the value which comes, you have to compare with critical value. Then you have to compare with critical value. And after comparing with critical value, you have to reach on conclusion that the birth of baby boys and baby girls are normal or not. Similarly, we can do If we talk about COVID-19, affected or non-affected, and if I'm talking about co-vaccine or another vaccine, so vaccinated or non-vaccinated. So we have some numbers like 150 vaccinated but affected, and 300 vaccinated but non-affected, and 275 non-vaccinated but affected, and 525 non-vaccinated and non-affected. So I want to check that is there any effect of vaccination on the COVID-19 infection. I want to check it. So this is what your observation. And what you have to do, you have to calculate the expected. How you will calculate the expected? On the basis of ratio. Because of there is only a base of ratio. What is the total of it? 150 and 275. Can anybody help me in case of a total of this? Oh, nobody is going to help me out. Why?
Sir, 450, sir. 450.
150 plus this. 450 is this.
Yes, sir.
That is what 425, if I'm not wrong.
Yes, sir.
Right. And this is what 5, 6, 7, and 8. 800.
800.
And the total is what 1250.
Yes, sir.
This is what I just taken the total of it. Now I'm going to calculate the expected value. How will I calculate expected value? It is very simple. 450, that means expected value for this. If I want to calculate expected value for this, the total of column, total of row, multiply and divided by grand total. That means 425 multiplied by 450 divided by 1250. Or
153, sir. 153.
153. The value is 153. Very good, sir. Now, for this, for 300, total is 825, 450. So this is what 825 multiplied by 450 divided by 1250.
297, sir.
297. And about this, for this 275, 425 and 800. 425 multiplied by 800 divided by 1250.
272, sir.
272. And this is what 800 into 825 divided by 1250.
528, sir.
528.
Yes, sir.
Right. So this is what our expected value. So what we will do, we have to write it down like this. Our observed value 150, 275, 300, 525, expected 153, 272, 297, 528. This is what observed, this is what expected. And if you have remembered, then I told you in previous session that how you will calculate. Just a minute, I'll take this. And I hope so it is visible to everyone, right?
Yes, sir.
So this is what my observed, this is expected, and 150, 275, 300, 525. And the expected value is 153, 272, 297, 528. Now what we have to do, we can easily analyze equals to chi-square test. Chi-square test. This is what your actual range comma. This is your observe, just entered. What is the value? 0.98.
0.98.
That means what you will reach on conclusion? The vaccination was affected or not? The vaccination was not affected. Yes or no?
Sir, it should be compared with the critical value, no, sir?
No, it is a p-value. This is what p-value.
Okay, okay.
This is p-value.
Yes, yes.
Right. So these are the, with the help of this, you can, or if I'm talking about a normal research paper, or I'm not talking about structure equation modeling, right? I'm talking about normal research paper. What you need? That is what? Frequency distribution, graph, then mean, standard deviation, standard error, skewness, then one sample test, two sample test, ANOVA, and chi-square test. Yes or no? We will apply only these things in writing a basic research paper or in this thesis. That is why I always say that Excel is more than sufficient to analyze your data. I hope so you enjoyed this session, if I'm not wrong.
Vijay, sir.
Any doubt, any question, please ask.
Brijesh, sir.
Yeah, please.
Sir, when I saw your face in the beginning itself at 4:30, then itself I put the chat box message. It is very happy to see you, sir.
Thank you very much, sir.
And I said I will enjoy, like I enjoyed more than 100%, sir.
Great, sir. Thank you very much, sir. Thanks a lot.
Yes, sir. Please, sir.
It was really wonderful session, sir. Once again, totally
Thank you very
practical
much, sir.
session. Totally practical session. We all enjoyed today's session. Any question you can ask to Brijesh, sir? If any question you can ask, you can unmute and you can ask. Yes, yeah. N.E.T ji, you want to ask something?
Yes, sir.
Please ask.
Sir, I want to know which tool I have to apply for the hypothesis. There is a significant association between mastering pronunciation and students' mother tongue.
Simple correlation, ma'am. Correlation test is more than sufficient for this thing. I'm not saying correlation, I'm saying correlation test.
Oh, correlation test, sir.
Yeah.
Okay, so how to perform, sir? That also you can.
Actually, what happened when you are going to find the correlation, it's going to give you the value of R only.
Okay,
right?
sir.
And when you are going to test correlation test, you will find the p-value as well.
Okay,
the
sir.
p-value is going to tell you there is a significance relationship between these two variables.
Okay, sir.
The relationship is there, but that relation is significant relationship.
Okay, sir. Thank you so much, sir.
Welcome, ma'am.
Yeah, Ramesh ji, any question?
Yes, sir. Please, sir. Good evening, Brijesh sir, Modi sir, both Ravikant sir and even SS Modi sir also. Sir, today really it's a big festival to us before Yugadi, sir. Sir is always excellent. I always like to attend his session, sir. So I special thanks to Brijesh sir and all organizers, sir.
Thank you, Ramesh ji. Thanks a lot.
Thank you, sir. Thank you.
Thank you, Ramesh ji. Any other question, participants? I think, sir, in the chat box also, they all are happy and they really enjoyed today's session. And before inviting Professor Mehta, sir, for vote of thanks, I request you all to please on your videos. And I would like to invite and welcome Professor Mehta, sir, Vice President, Inspira Research Association, to give formal vote of thanks on behalf of Inspira and KG College. Professor Mehta, sir.
Thank you, Dr. Ravi, for inviting me to move a vote of thanks. In fact, the chat box itself, the kind of compliments that Dr. Brajesh Awasthi has received, and few participants have expressed their gratitude towards Dr. Brajesh Awasthi, speak itself how effective he is in his session. In fact, one thing that really impressed me, that it was not a regular session for Dr. Brajesh Awasthi. In fact, we requested him to conduct this session at the last hour, but in spite of that, it didn't appear throughout the session that he was a substitute resource person for. He is as effective as the regular session. I'm really thankful to Dr. Brajesh Awasthi for helping us in this session. The session was extremely effective, and all the participants really liked the session and immensely benefited by your scholarship. I know Dr. Brajesh Awasthi since last 2.5 decades. He's a very, very hardworking resource person, faculty, a good teacher, very effective teacher. And whenever he conducts any session, I know it very well that he puts his heart and soul in that session. That was clearly reflected in this session itself. One thing is very clear, that in today's session and the session that Dr. Awasthi conducted day before yesterday, it is expected from all the participants that they should do continuous practice of all these practical tips and the guidance that Dr. Brajesh Awasthi has provided. I think Dr. Awasthi will agree with me that continuous and rigorous practice is very much required. Then only this session will be, not only this session, but the entire workshop will be benefited for the participants. Secondly, I know that there are many scholars who are not very much from commerce or not having any mathematical background, but it is expected from that they should know about all the basic statistics. All these tools will be useful for all the participants when they are well versed with the statistics, the analytical tool. Then they will be able to use all these Excel and the other software that are available. It's high time that research scholars must start writing their research papers, do rigorous practice, and whenever they find time, they should do continuous and constant practice. On behalf of Inspira Research Association, I'm highly thankful to Dr. Brajesh Awasthi for conducting this wonderful session. And we are looking forward for many more sessions. We will be organizing in Inspira many more research-oriented workshops and training programs. So we cannot afford that Brajesh Awasthi may refuse. So as a senior, as a teacher of Brajesh Awasthi, I can always force him to be part of Inspira and conduct workshops for us.
Anytime, sir, anytime.
Yes, yes.
You
just
so
give
me an order.
Yes, yes. Thank you so much. And I'm thankful once again to Professor S.S. Modi for his very dynamic leadership. He is the mentor for all of us. I'm thankful to Captain Ravi Kant Modi for organizing this workshop and working really very hard to make the workshop very successful. Last but not least, I'm thankful to each and every participant for their valued presence and their active participation in this workshop. Thank you once again. Thank you very much. And I hope that tomorrow also participants will take keen interest and they will participate in the equal spirit. Thank you once again. Over to Dr. Ravikant Modi. Thank you.
Thank you, Professor Mehta, sir. And thank you so much, Vijay, sir, once again for accepting our invitation to be the resource person of today's session. And thanks to all the participants for being with us. And tomorrow is the valedictory day of this FDP, the 7th day. The session, the topic is effective report writing, how to write thesis and research paper. I think very important topic is tomorrow. So, and which will be delivered by Dr. Meghna Chhabra from Faridabad, Haryana. So we will meet tomorrow at the same time, and we will send a feedback link also tomorrow. On the basis of this feedback, we will you will get your certificates also. So please fill this, submit this feedback mandatory. So thank you so much once again to all the participants. Thank you so much, Principal Ma'am, KG College. Thank you so much, Mehta sir. Once again, thank you so much, Vijay Shavasti sir. Thanks to all the participants. Have a good